Good evening. This is Angie with Beyond the Lecture, and today we're going to put in some discussion on covalent compounds. So earlier today I did a video on ionic compounds, and this is our second class of compounds that we'll talk about in chemistry. And just so you know, there will be basically handouts that you can print out to follow along or pull up on your device, whether it's an iPad or computer, or just simply use it for later reference. And you put some of your own notes on there to help you study for this particular section. So back to the actual video. So we're going to dive into the second section of compounds here. They're called covalent, and I already gave you a heads up in the previous video that these compounds are largely non-metals. Okay, so they are the elements that are in the upper right hand corner of the periodic table. There aren't that many, maybe a dozen or so, if that. And the process is here that instead of transferring electrons to make ions, to make fully charged ions, we're going to have some element of sharing here. So we're going to share electrons to create these covalent bonds between atoms to form a molecule or a compound. So I'm going to tap out here and visit the periodic table again real quick to show you what I'm talking about. And here it is. I sort of have it circled in purple, and we're talking about here for the nonmetals, we're talking about group 4 all the way to group 8. And I apologize, my little, I wonder why that's there. I'll leave that for another time. However, so we have group 14, 15, 16, 17, and 18, or we can also say groups 4 through group 8. Those are the columns in the periodic table. And we're talking about carbon, nitrogen, oxygen, fluorine, chlorine, sulfur, phosphorus, selenium, bromine, and iodine. Those are your most common nonmetals. The ones on the edge, silicon, arsenic, tellurium, those are metalloids, so they have partially metallic properties and partially non-metallic properties. So I wouldn't necessarily put those in the non-metal category, but there you have it. Not very many elements in this particular section. Now, what happens though is they can combine, like for instance, nitrogen and oxygen can combine in several different ways. You can have different numbers of nitrogen and different numbers of oxygen. So we have to switch up the naming a bit to tell us how many atoms of each element are in these compounds. So we'll go over some examples here in just a moment. So the first section here is just, again, definition. We have 2 or more non-metal elements that share. Okay, so no complete transfer. So we don't really need to be concerned about tracking charges, and because there's no complete transfer. So we're not going to track the actual charge like we do in ions. And then keep in mind, this is focused on the right hand side of the periodic table, and there's basically a sharing, no transfer. So I think I've said that too many times, but hey, you can't say it enough. All right, so some characteristics of covalent compounds. They aren't quite as they're not quite as strong as the ionic bonds that are formed between their respective elements. They do typically have lower melting points and lower boiling points than their ionic counterparts, and they do not tend to conduct electricity like the metals do. So those are just a couple of side notes there. And then we have the actual naming. So we'll dive right in. This video hopefully won't take too much longer here. Basically, you take the name the first element. We're basically going left to right here. You name the first element as it appears on the periodic table. And then we tack on a Latin prefix to indicate the number of atoms. And the only exception to this rule is we don't say mono. We don't pop a mono up in front of that element name if it's 1. We leave it off. I'm not sure why they did that, but it's a little bit of a shortcut there. So we have all the prefixes here We have mono all the way through deca. So you'll probably recognize these. Trying to think, I think we use these in geometry as well to signify how many sides a polygon has. So anyway, take a look, mono, di, tri. We have tetra, penta for 4 and 5, and then hexa, hepta, octa, nona, and deca to round out 6 through 10. Here's your exception here. I gave an example here of carbon monoxide. So we don't say mono carbon monoxide. We just say carbon monoxide. And most of us know that this is carbon monoxide is that dangerous gas we don't want in our houses and apartments and things like that. So, oops, sorry about the scrolling there. Now, when you name the second element, we do have to tack on the "ide," right? So just like in the binary ionic naming, we do tack on an "ide." The difference is you're going to see two obvious things you're going to see in a covalent versus an ionic compound is that you'll see these Latin prefixes. So you'll know right away you're dealing with the nonmetals and it's covalent. Yeah, of course, we'll have two nonmetals and we'll have the Latin prefixes in there. So those are dead giveaways for the covalent compound naming. Now we have a couple of examples here. We have N2O4. So we name that dinitrogen tetroxide. So you'll notice we have di in front of the nitrogen for 2, and then tech. I think they leave off the A, right? So, and I think you might even see, I think teachers might even accept that. The idea is that you have the correct prefix, right? But notice they did chop off the A, probably because they don't want two vowels next to each other. So they'll say tetroxide, tetroxide. Now, next door, I'll go ahead and erase this. Below here, we have a phosphorus trichloride, phosphorus trichloride. So notice we don't say monophosphorus, we just say phosphorus, and then we put that tri out in front of the chloride to say trichloride. We also have another common compound we'll look at is PCl5. That might be in my examples too. I don't remember putting that in there. I did not. Okay, yeah, so closely related compound would be PCl5. And we would name that phosphorus pentachloride. Okay. So how do we know, we have to designate that the number of chloride atoms by that Latin prefix. Otherwise, we wouldn't know if we're dealing with PCl3 or PCl5 in our chemistry problems. So we have some more examples. We have CO2 for carbon dioxide, sulfur trioxide. So remember, we do have, this can come up from time to time. I've seen problems, students have problems with this, SO3 2 minus. That's the sulfite anion, okay? And it's important to, the key difference here is that the SO3 2 minus, the sulfite polyatomic ion, is charged. It carries a 2 minus charge, as opposed to the SO3. We assume that would be a neutral. I just put that 0 up there to indicate that it is a neutral compound and doesn't carry a charge. So I wanted to clarify that. And as we go down the list here, we have tetraphosphorus decoxide, dinitrogen monoxide, and then we also have dichlorine heptoxide. So there are a lot of flavors here. You can have the same two non-metallic elements, but you can have different numbers. And then some, like for instance, like CO3. I don't think that's actually CO3 2 minus. That's your carbonate. That's your carbonate. Okay. I don't think there may be a CO3 out there. They might not always be stable or, common element found in nature, so you don't have to concern yourself with naming them, but just know we have different combinations of these non-metallic elements coming together. So there you go. There's a CO3 carbonate, and then we also have, I'll write that a little bit more carefully there, carbonate. Okay, so these are different. These are polyatomic ions versus the actual covalent compounds. One's charged, one is not. Okay, so when you see, and I think I just mentioned before here, that when you see Latin prefixes, they end in "ide," right away that these compounds are in the covalent compound category, and you can write them up accordingly. Luckily, you don't have to guess, right? So we basically write the chemical symbol for each element, and then you just add the subscript based on what prefixes you see or lack of. So for instance, for carbon tetrachloride, that's our first example here. We just throw in one C for because it's a single carbon, and then we put in 4 chlorides, or chloride elements for the tetrachloride part. Dinitrogen pentoxide. We have 2 nitrogens for di, and then we have 5, penta, that's our 5 prefix there. So we have N2O5. We have phosphorus tri. Well, look, they put 2. We put 2 I's there. So we have triiodide, PI, not PL, but PI. That would be, I write in Arial. I use the Arial font, so we don't have it's kind of hard to distinguish the L and the I, the lowercase L and the uppercase I. But there's PI3, and then we have silicon. Oh, there's a not transition, sorry. That's a metalloid. Silicon is right below carbon, and we'll see that in some of the examples here. So SiO2, that's for di for the 2 oxide atoms, and SiO2, that would be part of sand. It's very strong compound, very hard to break. So we have that. We have sulfur hexafluoride. So we have 1 sulfur followed by hexa. That's our 6, right? 6 fluoride atoms or fluorine atoms. We have 2 here, 3 here, 5 here. So definitely know your Latin prefixes. You'll probably have to memorize them at the college level, maybe not so much at the high school level. Again, it depends on the teacher. I'll go ahead and scroll down through here, and I think that's pretty much it. Yeah, we're on the downhill slide here. So naming, yeah, we're going to see a few repeats. Oh, there's my PCl5 number 3. So for N2O5, we'll just determine that we'll need to use di. I'm going to make myself some more room here. So we'll use di. Remember, you don't have to change the first element. It just stays the same with the Latin prefix in front. And then penta. Use pent. But if you look both of these up, they'll be pentaoxide and pentoxide are acceptable. So we have dinitrogen pentaoxide or pentoxide for number 1. For SF4, that's our sulfur. We don't need mono. Remember, mono is not needed on the first element. And we do need to indicate tetra for 4. Get tetrafluoride. And there's our PCl5. So we have phosphorus, no mono needed. And then we have we have 5 of those chloride or chlorine atoms. Now we have Cl2O3, so we'll need di. So di for 2 of those chlorine atoms, and then tri. So tri for 3, and then oxide. Remember, these all have ides on the end for the second part. Last but not least, we have carbon. No mono needed. And then tetrabromide. So we have a carbon surrounded by 4 bromine atoms. There you have it. So I like covalent. They're much easier, I think, than the ionic naming because you don't have to worry about balancing charges. You just simply go with what you're given for the prefixes and attach the number as a subscript or attach the Latin prefix based on the subscript. So last but not least, we have part B, and then we'll go over some tips and we're done. So we have nitrogen single, right? N for nitrogen. We have trifluoride. So we know we have fluorine with 3. Tri for 3, right? Tri equals 3. Now we have phosphorus next. And that's one we've seen already. Penta. 5 for penta. I'll just write that here. Dinitrogen tetroxide. That's a pretty popular one too. I think that's found in rocket fuel. Okay, I could be wrong, but I think that's found in rocket fuel. Okay, so we have dinitrogen, right? So that's 2. Tetro, that's our 4. So we have N2O4. Sulfur dioxide, 1 sulfur, 2 oxygen, because di is our 2. And then last but not least, we have tetraphosphorus hexoxide. Hexoxide, that's a tongue twister. So tetra means we have 4 phosphorus atoms, and hexa means we have 6 oxygens. Okay, so tetra is 4, hexa, that's 6. So 4 phosphorus and 6 oxygen there. And that is it. Tips for success. We'll just review this real quick. Double check the prefix, right? Just make sure you have the right prefix attached. They're all very different. So just knowing your prefixes. And don't forget to drop mono on the first element. You don't need to put it on there. And then the second element always ends with "ide." All right, so I hope you found this helpful. And again, you can find this outline, a review sheet on my website. And you can review the problems again, print it out, work the video. And I'll have a few examples out there as well that you can do in addition to the work we've done on this video. And you can always search for, covalent naming, samples with answers. Try to go with a school-related website, something that ends in .edu, because probably a teacher or professor did it. And keep practicing. Practice makes perfect. And I'm glad you joined me here today. Please hit like and subscribe if you'd like to be notified when more content rolls out. That should be happening on a daily basis. I'm going to try and crank out at least 2 or 3 videos per day, roughly, and to get this information out there to help chemistry students. Thanks again for watching, and have a great day.